this unit, we're going to look at polygons. Really, the entire unit is on polygons. We will eventually focus on a specific type of polygon, which is a quadrilateral. How many sides on a quadrilateral? 4. Quad means 4, right? So after this week, really, we're going to look at just 4-sided figures. If you have a glance, you can read through this. I'm not going to read through it at the moment, but gives you a highlight of what you're going to learn in this lesson. Okay. How many of you play video games? A few of you. Do you know much about how they're developed? Say it louder. What do you know, Riley? Yeah, most textures are made of polygons. And I don't know how many of you knew that. Recording. DJ, what's your problem? On this, I'm not going to read through all of it, but when you look at 3D graphics, really the most basic figure it starts with is a polygon. What's our most basic polygon? Triangle, yeah. In this case, this house is made up of, I think they say 14 triangles if you count them all up. And then you add action to it, right? And it used to be 0 to 30 in 1 second. This is old data, but I'm going to read this part to you. In a video game, the computer programs that make up the game have to display a new image on the screen every 30th of a second. That means the video game's computer has to calculate all the polygons, the lighting effects, the player movements, the explosions, and other stuff in a 30th of a second. Again, this is old, right? So 0 to 30. Now it's 0 to 60. So frames per second used to be at 30. Now it's at 60. And I was visiting with Mr. Schulte. They can even be up to, how many do you guys know? 120, which is really, really fast. Okay? In modern times, though, polygon count is no longer even considered a serious problem because the technology has advanced so much that it can deal with the polygon count. And again, I'm not going to go through all of this. There's other methods, right, to create those 3D models. But in the blue, it should be kept in mind, though, that polygons are still the basis of all 3D graphics, with no exceptions. If it weren't for polygons, 3D graphics could not exist. All right, here's some other examples. Up here, this guy. What happens when you have more polygons? Yeah, more defined, right? What's this place? Pentagon, which is just 5 sides, shape of a pentagon. This is basalt. In nature, all of these shapes occur, some more often than others. When basalt cools, it forms hexagonal columns. Snowflakes, the next time it actually snows versus the mist that's outside, like look closely at a snowflake, starts as a hexagon, and depending on the humidity and the air temp and how long it gets to fall, the more detailed it gets. What's this? Honeycomb. What shape is in the bodies? How many sides? 1, 2, 3, 4, 5, 6. What do we call a 6-sided figure? Hexagon, yeah. Here's a flower with 5 sides. Pentagon. Just some more 3D graphics so you can see like how it started, the polygons. Then you add more and it gets its definition. You guys know what this is? It's a what? Yeah, do you know for what? It's chemical structure for, it's not sugar. I should find a sugar one though. It is down here, this guy. What's this guy? What are these things? They're coffee beans, caffeine. It's caffeine structure. I don't know if any of you watch some wrestling. What shape is this thing? Octagon. Okay, page 1. Did you fill in most of it? Top part, maybe not. Top didn't show up in your video, but polygon closed figure, fill that in. So there can't be any gaps, can't be any overlaps. Formed by 3 or more line segments. And those segments are called sides. We've been working with polygons really all along, with the triangles that we've been working with, or some of the other figures when we did similarity or congruent figures. In addition, which didn't show up in the definition, the points on the outside individually are each a vertex. Vertices for plural. Okay. And then you know what angles are. You guys really know what sides are too. These things that were drew across are called diagonals. Okay. So you have vertex or vertices on a polygon, sides on a polygon, angles, and then diagonals. Okay. I don't know, triangle, how many degrees in a triangle? 180. When you look at the quadrilateral, how many sides on a quadrilateral? 4. When we draw on the diagonal, how many triangles are formed? 2. Every triangle is how many degrees? So how did we get that 360? Yeah, times 180. And then it follows on, right? Did you fill in the rest of this? Oh, I meant to cover these up. I ran out of time. How many sides on a heptagon? 7. Did you guys have to look that up yesterday? Or did it show up in the video? How many sides on an octagon? 8. Non means 9. You will need to know these. How many years in a decade? 10. So deca means 10. Okay. And we do have a dodecagon. I like to think, like dos in Spanish means how much? 2. And deca means 10. So 2 plus 10. Dodecagon is 12. Number of triangles is still how many less than the number of sides? 2. Okay. What'd you get for this degree measure? Did you fill it? 900. Okay, how about the next one? 12. Yeah, this one 1,080. Oh. And then was it? 1,260. Thank you. And then what did we get for a 10-sided figure? 144. Okay, so formula-wise, when you guys think about formulas, eventually you move from specific numbers, right? Here we have specific scenarios. Well, what if we just had any number of sides, right? Whether it's 15, 20, 120, can we come up with a formula for it? So if we let n represents the number of sides, how do I get the number of triangles? Minus 2. And then we took this number times what? 180. That's how formulas come about, right? Eventually you switch from a specific case to a general case. Okay, and then did you do the 4 at the bottom? All right, what'd you get for 15-sided figure? Say it louder for me. 2340. How about a 21 gun? 420. How about a 48 gun? 8230. And then 36 gun? 6,120. Okay. With these, and maybe you notice why is it called a 15 gun? Once we get past 12, there are still prefixes for 15. This is a pentadecagon, but they get to be pretty cumbersome when we look at those prefixes. So anything past 12, if something has 13 sides, we just call it a 13 gun. Or if it had 33 sides, 33 gun. Okay, check number 3. What should it be? 828. Really easy fixing these. Okay, make sure you fix it on your paper. Thank you. Okay. You ready to flip? Flip page. Goal in this lesson, we're going to just look at interior angles today. Tomorrow we'll look at exterior angles. Before we get to that, though, we have some specific types of polygons. What does equilateral mean? Remember? All the sides are the same. Okay? And to mark your sides, you use your congruence marks. This shows the sides are all the same. How about equiangular? All the angles are the same. And we use arcs for angles, so that's why these have arcs by it. And if you have a polygon that's both equilateral and equiangular, then we call it regular. Okay? We're not going to write out that it's equilateral and equiangular. We're just going to say it's a regular hexagon. Okay, let's proceed. This we already did, so you guys can just fill in your formula. The sum of the measures of the interior angles has to be interior. N minus 2 times 180. What does N minus 2 stand for? Not the N minus 2, just N. What does N stand for? Yeah. What does the N minus 2 stand for? Which tells us what? Yeah, the number of triangles. And then 180, because there's 180 degrees in every triangle. Okay? Hayden? All right. Find the sum of the interior angles of each polygon. Heptagon. How many sides on a heptagon? 7. And if you don't know right now, then you look back and look it up, but hopefully you get to a point where you know hept means 7. So I'm going to write 7 what? Minus 2. And then we're going to take that times 180. 7 minus 2 gives us what? 5. Times 180 is measured in degrees. Okay. Let's skip to C. Dodecagon. How many sides on a dodecagon? 12. And again, 12 minus 2, because that tells us how many triangles we could draw if we needed to draw a dodecagon and draw the triangles. What's 12 minus 2? Times 180? Yeah. You do need to be careful with directions. Like, it will become an issue, just to give you a heads up. So make sure you're thoughtful on this one. We're finding the sum. So I stop once I get the sum. I'm not going to do anything else. Eventually we'll get to exterior angles. In this case, sum of the interior. That's it. Okay? Given the sum of the interior angles of a regular polygon, find N and name the polygon. So now we're reverse. We already know the sum. How do I get to this sum? What's the process? Yeah, tell me first, what was our first step if I wanted to get to this answer, though? You would plug in, right? If we knew the number of sides, we would plug in. In this case, do we know the number of sides? No. Well, do we, like, at the moment? Just with this number? No. So n minus 2 times 180, I know that has to equal 540. And some of you will get to the point where you know 540 means there's this many sides, and if you're there, awesome. Not everyone's there yet, okay? And then we're going to work backwards. What should I do first to work backwards? Divide by 180. We're going to undo the multiplication. What's 540 divided by 180? And 3 isn't the number of sides yet. That's the number of triangles. How do I undo the minus 2? Plus 2. So n equals what? 5. What do we call a 5-sided figure? Pentagon. Okay, I'm going to give you guys a moment. I'm going to let you try C. Okay, we're going to skip B. Follow that, see if you can figure out C. Make sure you guys skip B for the moment, do C, so you can compare your answer with your neighbor.
How many sizes? So, like 16.
Close. Show your work, you'll get it though, you're close though. Once you have it, compare with your neighbor, see if you agree. It's at 14. What are you coming up with? 16. What do we call a 16-sided figure? Yeah, it's just a 16. That's it. Okay? Alright, you ready for A on the bottom? When you look at A, are those interior angles or exterior? Interior. Do we know what they should all add up to? How do you know it's 360? How do you know a quadrilateral is 360? If you don't know the sum, and again, some of these, hopefully a quadrilateral you'll memorize is 360. If you don't know, first step, find your sum. So we're going to do 4 minus 2 times 180. What's 3 times 180? Not 3 times 180. 2 times 180 is how much? Two times 180 is? Yeah. Okay, so then I know for sure those 4 interior angles have to equal 360. So how do I find the missing measure? Yep. Okay, so I'm going to write it like this, x plus these. Will you guys add these up for me? What do you get if you add them up? Okay. And I know this 4th angle plus 296 has to equal 360. What do I do to get x by itself? What are we left with? Okay. You ready for B? On B, how many sides are there? 6, 7, 8. There's 8 sides, right? Oh, you know what the issue is at this part? There's actually a little point here, which is tough to see. You can also count the angles. Number of angles and number of sides, they're always the same. So if it's easier to count the angles, count them up. There's 8. So first step, we have to find our sum. So we're going to do 8 minus 2 times 180. 6 times 180 is what? So when I combine all of these, they all have to add up to 1,080. I'm going to combine my x's first because those are like terms. What's 2x plus x? 3x. All right, you guys want to add up all of the other angles? 800. 815. What are we going to do next to solve? Minus 815. Which leaves us with what? And then last step, divide by 3. What do you end up with? You guys agree? saying you're wrong, it just doesn't feel right. But we'll have Mr. Schulte check it and we'll come back. All right, on C, how many sides? There's 5. So first step, we're going to do 5 minus 2 times 180. What's 5 minus 2? 3. Times 180 is what? 540. Okay, so solving wise, we don't really have x's. Can we put an x down? What are we trying to find? Which angles do we not know? X and y. And these two are marked congruent, so you could put x for both of them if you want. Some of you, if you have good number sense, you know to take 540 and minus this, and this, right? Go for it. But otherwise, I have two angles that are the same, so 2x plus what? What am I going to add together? Yeah, 119.47, and angle Z is 90 degrees, so we can't forget about that one. Add those up, what do you get? 256. Subtract 256. What's 540 minus 256? What is it? And then divide by 2, what do you get? Ooh, that's a 1. I'm like off in this corner. 142. Are we good?
Yeah, I think so.
Okay. All right, flip the page. We're gonna do just a couple more, and then we'll call it a day. For each interior, before I show you a formula, because to be honest, I really don't think you need a formula to find each interior. Keyword, you do need to be careful. Each, that's how many? 1. And then we're still with the interior. So first step, can I figure out what all the angles add up to in a pentagon? Mm-hmm. How many sides on a pentagon? 5. What's 5 minus 2? 3. 3 times 180? 540. Is that my final answer? Mm-mm. I want one angle, and if it's regular, what do we know about all of the angles? They're all the same, yeah. So how do I figure out just one of these? Divide. There's how many of them? 5. So you're going to take 540 and divide by 5, which gives us what? That's it, okay? Could you do that without knowing a specific formula? Yeah. Process-wise, you're still going to find your sum, and then you divide by the number of sides or number of angles. And again, number of sides and angles, they're always the same, so that n you can interpret both ways. So if you want to fill that in, fill it in. I don't know that you really need it. You do C. Try C on your own. Besides that, do decagon. Yeah. Do we stop at 1800 degrees? No, because we want one angle. How many angles on a dodecagon? So then 1800 divided by 12? So like 150?
Yeah.
150. Are we okay on those? Assignment-wise, you have an option. I'm not going to collect anything tomorrow. You have till Friday once we finish up notes tomorrow. If you want to get a head start, you can work on 1, 3, 7 through 12. You guys see this? And sometimes, like tonight, if you're not as busy as maybe you would be tomorrow night, maybe get those problems done. Okay? Let me see. Yeah, is that through 12? You can do 1, 3, 7 through 12. Yeah. 1, 3, yeah, and then the bottom part, 7 through 12. Yeah. Tomorrow we'll finish up notes and then you'll work, all right?